1. Welcome to our EMT lecture series number 1. In this lecture, we are going to discuss on vectors. We begin by recalling what are scalars. Scalars are quantities that can be described by magnitude alone. They include mass, time, temperature, and distance. Now, how about vectors? Vectors are quantities that can be described or are being described by their magnitude as well as direction. These include velocity and force. For a vector A that is being separated from the origin by A is mathematically described with the equations or relations as shown on the slide. The unit vector is equivalent to the vector divided by the magnitude of the vector. In our course, the vectors is going to be denoted by an arrow or a bar, while unit vector is being denoted by a cap. For the arrow vector shown on the slide, in a three-dimensional Cartesian or rectangular coordinate systems, it would have three direction components or three unit vectors in the x, y, and z directions. Let's suppose we have a point P in a rectangular or Cartesian coordinate system. Based on the illustration shown on the slide, how can we represent vector P from the origin to point P? It would be given by vector P equivalent to 3x plus 4y and 5z unit vectors. Let's suppose we have two position vectors, Rp, that is the radius vector from the origin to point P, and Rq, the radius vector from the origin to Q. The third vector from point P to point Q would be defined as shown. Now, consider a vector A with A equivalent to AX in the X direction plus AY in the Y direction plus AZ in the Z direction. The magnitude of that vector A is equivalent to the square root of AX square plus AY square plus AZ square. From the previous slide, we can thus conclude the unit vector of vector A is equivalent to that vector A divided by square root of AX square plus AY square plus AZ square. Okay, look at the example on the slide. Can we identify or determine the vectors from A to B as well as the magnitude? The vector would be equivalent to 2x plus y plus z with the coordinate of B subtracting coordinate of A. The magnitude, on the other hand, can be calculated based on the vectors to be equivalent to square root of 6. Vectors can be added together, and on the other hand, vectors can be subtracted from one another. Vectors also follow several laws, including associative, commutative, distributive, plus multiplication by scalar laws. It is a common practice to visualize addition and subtraction of vectors in order to fully understand the implication of the addition and subtraction process. Let's now look into an application of vectors for a given problem. Let's say we have an aeroplane flying in the west direction at 350 kilometers per hour. And there is also wind blowing in the northwest direction at 40 kilometers per hour. Due to this wind, we are now in need to calculate actual aeroplane speed and direction. We are going to use compass directions and applying the compass directions to two-dimensional or 2D Cartesian coordinates. Looking at the problem statements, we can identify three vectors involved in this problem. The vectors include UP, that is the velocity of aeroplane in the absence of wind, UW, wind velocity, and UZ, observed velocity that need to be calculated. UZ is equivalent to UP plus UW. UP is equivalent to 350 in the negative x direction. UW, which is in the northwest direction, has x and y components. Using Pythagoras theorem, we can have UW equivalent to 40 divided by square root 2 negative x plus y. Adding them up, we will get negative 378.28x plus 28.28y kilometers per hour. This rectangular format speed or velocity can be changed to polar format. Thus, UZ is equivalent now to 379.3 with an angle of 175.72 degree kilometers per hour. We have looked into vectors addition and subtraction. We are now going to look into vectors multiplication. When two or more vectors are multiplied, they can have results that are either scalar or vector in values. The two vector multiplication techniques are known as dot product or cross product. Dot products of vectors A and B is defined as the product of magnitudes of A and B and the cosine of angle between A and B. Let's suppose we have two vectors A and B as shown on the slide. Two vectors A and B are said to be perpendicular to one another if the dot products between them is equivalent to 0. Reasons being is that two different unit vectors would be separated by 90 degrees. And based on definition of dot products, the cosine of 90 degrees would become 0. Dot products of two vectors follows commutative and distributive laws. It is mentioned earlier that when we have two unit vectors that are different, dot product between one another would result in 0 value. On the other hand, when we have two similar unit vectors, dot product between one another, the end result will be a scalar value of 1. The second vector multiplication technique is known as the cross product. Cross product between vectors, supposedly A and B, is the magnitude of A cross B and is equivalent to the product of magnitudes of A dot B and sine of angle between A and B. When vectors A and B are cross product between one another, the resulting vector would be having direction that is perpendicular to the direction of A and B. When we have vectors A and B as shown on the slide, the cross product between A and B is equivalent to AY BZ minus AZ BY in the x direction plus AZ BX minus AX BZ in the y direction plus AX BY minus AY BX in the z direction. It can also be written in matrix form that can be more easily remembered. Cross product does not follow commutative and associative laws, but it is distributive. When we have two different unit vectors that are being cross product, the result would be a different unit vector that is dissimilar from the two original unit vectors. This can be easily remembered using the cyclic permutation concept as shown on the slide. Let's try one final exercise or example for this lecture. If we have two vectors P and Q and we need to find the dot product, cross product and the angle between the two vectors, the techniques on how to solve the problems would be: first, to use this approach to find the dot product. Next, this approach to find the cross products, and the angles between the two vectors can be obtained based on the definition of dot product. In our next lecture, we are going to discuss three coordinate systems that are going to be used in our course.